All right, so we're going to start with reviewing a little bit of what we did yesterday. So the question I left off with yesterday was bromine. And if I take a look at bromine from the worksheet that you were assigned, I want to figure out, where does bromine land in the periodic table? Bromine lands in the fourth period in the P block, and it's 5 over. So I know that it ends in 4p5. Okay, bromine ends in 4p5, and you can see I already have that written down there. Now, because bromine ends in 4p5, I know that everything that comes before that is filled. And I always start with 1s. And I go from 1s to 2s to 2p to 3s to 3p to 4s to 3d to 4p. And that's where I'm at. So again, I'm going to go ahead and I'm going to start with 1s, go to 2s, 2p, go to 3s, go to 3p, then 4s. Now remember, after 4s, I am now going through my D block. So here's 4s. This is now 3d because it's a period number minus 1. So I'm now going to go 3d, and I'm going to write that 5 times because there are 5 d orbitals. Okay? So 3d, 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 3d. And then I'm going to end with 4p, and I'm going to write that 3 times because there are 3 p orbitals. Okay? Draw my lines. And I know that 4p, or that bromine ends in 4p5, so I know that there are 5 electrons in there. And now I know that everything before that is filled. 1s is filled, 2s is filled, all my 2p orbitals are filled, all my 3p orbitals are filled, 4s, all my 3ds, so on and so forth. Okay? We'll do one more. We'll look at argon, because argon is pretty quick. Here's bromine. That's what we just did. Here's argon. Argon ends in 3p6. So if I look at argon, I know argon ends in 3p6. I already have a configuration that goes out to 3p6. So all I would have to do is that. Okay? All right, now I'm going to switch it up and I'm going to go back to this worksheet. And we're going to talk about electron configuration notation, both longhand and shorthand. Okay? For electron configuration notation, it's actually easier. We are going to get rid of the arrows, and we are going to get rid of writing out all the orbitals more than once. So you're only going to have to write the p orbitals once. You're only going to have to write the d orbitals once. You're only going to have to write the f orbitals once. Okay? And instead of having the arrows indicate electrons, we're just going to use a superscript. Okay? Or an exponent, if you want to call it that. And that's going to tell us the number of electrons total in those orbitals. And this is why when we were pointing out how to figure out where they land, I had you write it in a certain way. Okay? And the reason I had you write it that way was so you would be really comfortable when you had to write it for electron configuration. So if I look at carbon, and I'm just going to copy this real quick, and I'm going to move it down to the bottom sheet. Paste it. Okay, so this is carbon. Carbon was 1s with 2 electrons, 2s with 2 electrons, and in my 2p orbitals total, I had 2. And we said that carbon ended up ending in 2p2. Okay? Now, to write it in electron configuration notation, by the way, this is orbital or electron spin. Okay, the next one is just electron configuration. All right? And that is essentially getting rid of the arrows. So instead of 1s with 2 arrows, 2s with 2 arrows, and then the 2p each with 1, you're just going to go 1s, 2, because it has 2 electrons, 2s, 2, because it has 2 electrons, and 2p2, because it has 2 electrons. If I add up my exponents, or my superscripts, it needs to equal the number of electrons in that element. So carbon has 6 electrons, I have 2 plus 2 plus 2, and that means there's 6, therefore I'm good. Okay? Let's go to the next one. Fluorine. I'm going to go ahead and copy fluorine down. And I'm only showing you the electron configuration notation because I think it makes it easier for kids to understand why I'm doing this. Okay? So fluorine, I know, ends in 2p5. So now I got to figure out what orbitals I have and what's full. And I know 1s is full, so it's 1s2, 2s2, and then 2p5. If I add these up, 2 plus 2 plus 5, okay, that gives me 9. Fluorine has 9 electrons. So you can see this is easier, and it's also quite a bit faster. Let's look at another one. We're going to skip beryllium again, but let's go to magnesium. Okay, magnesium ends in 3s. Okay, ends in 3s with 2 electrons. So for beryllium, again, I start with 1s, and there's 2 electrons. 2s has 2, 2p has 6, and 3s has 2. I'm going to go ahead and move this down to where beryllium actually is. Okay, so this would be the electron configuration for beryllium. Okay, electron configuration notation. Let's look at phosphorus, and let's do phosphorus without even looking at the orbital notation. Okay, phosphorus, I know, ends, this is 3p, ends in 3p3. Okay, so phosphorus ends in 3p3. That I know. So again, I start at 1s, and I know it goes 1s with 2, 2s with 2, 2p with 6, 3s with 2, and then 3p with 3. Okay? So I have 1s2, 2s2, 2p6, 3s2, 3p3. Okay? Let's try it again. Let's look at argon. Go back up to our periodic table. I'm actually just going to try and move this down. If it'll let me, it will. Okay, let's go back to our periodic table. Let's find argon. Argon is group 18, right there. Okay, that ends in 3p6. So argon is going to look a lot like phosphorus, only it's going to be 1s2, 2s2, 2p6, 3s2, and not 3p3. I know argon ends in 3p6, so 1s2, 2s2, whoops, 2p6, 3s2, 3p6. Okay? Calcium. Calcium is way up here. It ends in 4s, 2 over. So I know calcium ends in 4s2. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. It's done. Okay, we're just eliminating the arrows. That's really all we're doing. We're getting rid of the arrows, and we're only writing each orbital once. So what does this actually tell us? This tells us that the only orbital that should not have a 2, a 6, a 10, or a 14 after it for an exponent is your last one. Your last orbital is only ever going to be the orbital that's not completely filled. So let's look at arsenic. Arsenic ends way over here. Arsenic ends in 4p3. So I got to go through 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Okay, so let's go ahead and write that down. I know that this ends in 4p3, so I know that it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Okay, let's look at bromine. Bromine up here, okay, it's in 4p, and it's 5 over. So again, let's cheat on this one. Bromine looks just like arsenic, only instead of ending in 4p3, it's going to end in 4p5. It's that easy. Okay, notice every orbital in the beginning, they all have a 2, a 6, or a 10, and if you went through the F block, it would have a 14. Only your last orbital will it ever have any number other than 2, or 6, or 10, or 14. And it can have those numbers, it's just that's the only one that will have a number different. Okay, last one is tin. If I look at tin, tin is way over here. Okay, it's in the 5th period, it's in the P block, and it's 2 over. So that ends in 5p2. So I'm going to go ahead and go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p, and we said it was how many over? 2. So that would be the electron configuration notation. The next thing that I'm going to show you is how to make it even shorter. And to make it even shorter, you're going to use what's called shorthand or abbreviated or a noble gas configuration. Your noble gases are found in group 18. Okay? These are your noble gases right here. This is group 18. These are the noble gases. Okay? When we do a noble gas configuration, we are going to go ahead and we are going to use the noble gas to abbreviate how much we have to write out. To do that, you always use the previous noble gas. So I'm going to go ahead and I'm going to erase some of this electron spin. Get rid of it. And I'm going to slide this over so we have room. And I want to look at carbon. And I want to find the noble gas that comes before it. So I'm looking at carbon. Okay? The noble gases close to carbon are helium and neon. Now when I'm looking at carbon, neon comes after carbon. Helium, however, comes before carbon. So I always want to use the noble gas that comes before the element, not the one that comes after. So in this case, I'm going to use helium. All right? Helium's electron configuration is 1s2, right? We know that. If I said draw out helium's electron configuration, you would put 1s2 and that would be helium. So what your abbreviated or your shorthand electron configuration can do is it will use the noble gases to account for those individual configurations. For example, this right here is essentially helium. All right? So if I want to do the shorthand configuration for carbon, I am going to put He in brackets, and then I'm going to put whatever comes after helium's configuration, which is 2s2, 2p2. So this is shorthand or abbreviated electron configuration. Okay? Let's look at fluorine. Let's slide that over. Fluorine is way over here. The noble gas that comes before it is helium. Remember, neon comes after it. The noble gas that comes before it is helium. And again, this is helium's configuration, 1s2. So I'm going to go ahead and I'm going to put in helium, 2s2, 2p5. Now, for the S and the P, for the 2s and 2p, you don't gain a whole lot. Helium isn't a very big noble gas. As your elements get bigger and you move down the periodic table, you're going to save yourself a lot of writing by using the noble gas configuration. Let's just look at magnesium. Here's magnesium. Magnesium ends in 3s2. The noble gas that comes before neon, Mg is 12. The noble gas that comes before magnesium is neon. Okay, the one that comes after has a greater atomic number is argon. We don't use that one. We always use the one with the next closest smallest number. So magnesium has an atomic number of 12. Neon has an atomic number of 10. That's what we're using. And remember, you only use the noble gases. If you're putting anything in parentheses other than He, Ne, Ar, Kr, Xern, or UUO, you're doing it incorrectly. We only use the noble gases. Okay? So let's get back to magnesium. Magnesium's noble gas is neon. I know that neon ends in 2p, 1, 2, 3, 4, 5, 6. I know that neon ends in 2p6. So because neon ends in 2p6, if I take a look at this configuration, this is essentially neon. Okay? So when I rewrite this for shorthand, it would look like this. Okay? Because the Ne is going to stand for everything in the brackets. And you're just picking up where the Ne leaves off. Okay? Let's look at the next one. Phosphorus. Okay? Phosphorus is right here. So if this is phosphorus, the noble gas that comes before it has an atomic number of 15. Is it neon, which has 10, or argon, which has 18? Obviously, it's neon, which has 10, because neon, or 10, is less than 15. Argon, which has 18, is greater. We have to use the one that comes before it. I can't stress that enough. All right, so let's go back and let's look. We know that neon ends in 2p6. So if I look at this configuration, again, here's neon. So if I want to do the shorthand for phosphorus, it's going to be Ne, 3s2, 3p3. Okay? Let's look at argon. Argon is an interesting one. Why? Because argon is a noble gas. You can't just put argon in parentheses and call it good. You've got to use the one above it. You have to use neon. Okay? So I know that neon is the previous noble gas. I know that neon ends in 2p6. Okay? So I can pick up right where neon leaves off. I can put neon in brackets. It ends in 2p6. And then I can go 3s2. And then 3p6. So to go ahead and do argon, I know that it's going to be Ne, 3s2, 3p6. Okay, next one is calcium. So here's calcium, atomic number of 20. It ends in 4s2. The noble gas that comes before it is going to be argon, 18. Okay, I know that argon ends in 3p6. I know calcium picks up at 4s. So all I have to do is put argon in brackets. I know argon leaves off at 3p6, so I want to pick up where argon leaves off, and that's 4s2. Okay, and if I highlight it, this essentially is argon. So we're shortening it up by that much. And you can see that as these elements get larger, doing the noble gas configuration will help a lot. Okay, it will actually make these quite a bit shorter. So let's look at arsenic. Arsenic is right here, number 33. The noble gas that comes before arsenic is argon. So again, we know argon leaves off at 3p6. So I'm going to go argon in brackets, 4s2, 3d10. And if I get to arsenic, it's 4p3. So going back down, Ar, 4s2, 3d10, 4p3. That's arsenic. Okay. How about bromine? Okay, let's go ahead and let's look at bromine. Look at the periodic table. Bromine is right after arsenic, so it's going to look almost identical. Again, the previous noble gas is argon. It is not krypton. The previous noble gas for bromine is argon. So I'm going to go ahead, put argon in brackets. I know that argon left off at 3p6, so 4s2, 3d10, 4p5. Okay, we're just shortening it up. And then the last one is tin. I'm going to come over here on tin, find it. Tin is right here. Tin ends in 5p2. My previous noble gas is krypton. Krypton ends in 4p6. Okay, because krypton ends in 4p6, I know that I need to pick up where 4p6 leaves off, and I have to go to 5p2. So I'm going to go Kr. It ends in 4p6. So then I go 5s2, 4d10, 5p2. And if I compare that to the longhand electron configuration, essentially this is krypton. We're just shortening it up. Okay? The last one that you have to know is called electron dot, and this is the easiest one. Okay? When we have electron dot, what we're looking for is how many outer shell electrons does an element have? And the outer shell electrons are based on your s and p orbitals that are in the same energy level. Okay? So if I look at group 1, every element in group 1 ends in 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. Okay? This is going to be your highest s orbital. So because it's all s1, every element in group 1 is going to have one dot. These are group 2. They're all going to end in s2. Because your s orbital is always the highest principal energy level, every one of your elements in group 2 are going to have two dots. Now let's get to groups 3 through 12. We don't even do dots for groups 3 through 12. And the reason we don't do dots for 3 through 12 is there's just too many of them, and they don't follow the same pattern. Okay? We don't worry about 3 through 12. We do, however, pick up with 13. If I look at group 13, this ends in S and a P1. All right? Now, let's go look at an element like gallium. Okay, gallium would end in 4s2, 3d10, 4p1. My highest s and p orbitals are the fourth. And I'm going to get 2 electrons from s and 1 electron from p for a total of 3 electrons. So group 13 will have 3 dots. We don't count the d orbitals. Why? Because it goes 4s, 3d. That 3 means they're at a lower energy level, and we don't count them. 4s, 3d, back up to 4p. Now they count. And remember, they have to be the same. I can't use 3p and 4s. Okay, I can't use 4p and 5s. it has to be the number of electrons in 3s and 3p, or 2s and 2p. Okay, has to be. So that's where I want to be looking at. That's the number of dots. So group 1 had 1 dot, 2 had 2 dots, group 13 had 3 dots, group 14 is going to have, guess how many? 2 from the S, 2 from the P, 4. Group 15 will have 5, 16, 6, 17, 7, 18 will have 8, except helium, which will only have 2. Okay? So basically, to figure out how many dots an element has, you just have to look at what group it's in. Group 1 has 1, 2 has 2, 13 has 3, 14 has 4, 15 has 5, 16, 6, 17, 7, 18, 8. So let's go ahead and look at some of these elements, and we'll do dot notations for them. I'm going to go ahead and shrink this a little bit because I want to be able to see both. All right, so let's look at carbon. Carbon has 1s2, 2s2, 2p2. All right, carbon's highest principal energy level is the second energy level. Okay, its highest principal energy level is the second energy level, and there are a total of 4 electrons in there. So for carbon, I would draw a C, and I would put 4 dots around it. Also remember, carbon is in group 14. Every element in group 14 is going to have 4 dots because every element in group 14 is going to still end in P2. And you're still going to have the 2 electrons from the s orbital. So let's look at fluorine. Okay, fluorine is in group 17. Okay, and we know group 17 has 7 dots, but let's talk about why. Okay, fluorine has 7 dots because, again, my highest principal energy level is the second. These are my highest principal energy levels for the S and the P. Okay, notice I'm not counting 1s and 2. I'm just counting 2s and 2p, and there's 2 plus 5 electrons for 7 dots. So fluorine, 1, 2, 3, 4, 5, 6, 7. Now, it doesn't really matter where you put the dots. You just put 1 on each side. Think of it as if it's in a box, and you center those dots, and you put 4 on each side of the box before you'd ever put 2. So on this one, you can see that I have a pair, and a single. Okay? Magnesium. Magnesium is in group 2. The highest principal energy level for group 2 is the third, and there are only 2 electrons. So Mg will just have 2 dots. Phosphorus. Okay, phosphorus is in group 15. If I take a look, my highest principal energy level is the third. So if I add up my electrons, there's 5. So phosphorus gets 5 electrons. It also just so happens to be in group 15. Remember, every element in group 15 is going to have the same configuration, whether it's 3s2, 3p3, or whether it's 4s2, 4p3, or whether it's 5s2, 4d10, 5p3. They're all going to have the 2 plus 3. That's why every element in group 15 is going to have 5 dots. Let's look at argon. Argon is group 18. Highest principal energy level. I got to add the 2 and the 6. Remember, every element in group 18 has 8 dots except helium. Helium only has 2. Okay? Calcium. Calcium is in group 2. The highest principal energy level is 4. Now notice, I'm not taking the 3p6 and the 4s2. I'm not adding them together. Why? Because the third energy level and the fourth energy level, even though it's an s and a p orbital, cannot be added together. It has to be 3s and 3p or 4s and 4p. It can't be 3p and 4s. Have to be the same energy level. So the highest energy level is the fourth. That's the only one that matters. So calcium gets 2 dots. You should also know that because calcium is in group 2. Okay, arsenic. if I look at this, you should be able to figure out how many dots arsenic gets. 2 from the S, 3 from the P. So arsenic, 5 dots. Bromine is in group 17. 2 from the S, 5 from the P, 7 dots. Two, 4, 6, 7. There we go. And then our last one is tin. Okay? Tin has 5s2, 4010, 5p2. I'm only counting the 5th energy level because it's the highest S&P. It's also in group 14, meaning that it only has 4 dots. Okay, I hope this video helps you out a little bit. You can watch it tomorrow, or the sub maybe we'll play it. But this is basically what we're going to be doing. I want to go over this on Friday and possibly quiz on, at the very least, the orbital notation. But we'll see where you're at and kind of see how comfortable you are. All right, hope you guys all have a great day. If I don't see you tomorrow, have a great weekend.